All right, my friends. Usually I don't like to make a whole notes video on just how to solve the delta math problems. You guys are too smart for that. Usually I like to give you a little bit of context, give you the why behind what we're doing. But these are pretty hard. This algebraically is probably the hardest thing we've done so far this year, and it requires a little bit of thinking as well. So as you're taking notes here, make sure you're capturing my work very, very accurately. Make sure you pause if you need to, and so on and so forth. In these problems, we're asked to solve for the domain of the function analytically. And analytically just means like algebraically, right? So we're showing the work that backs up our answer. And notice we have a new type of function that we haven't really dealt a whole lot with yet. This is called a rational function. And we need to find its domain, right? And I'm giving you the graph here, although when you find these in the wild, you will not be given the graph. And notice it has two x values that are not in its domain, right? And that looks like x equals -4, it skips, and x equals +2, it skips. Okay, so if I wanted to write down this domain, I could, based on the graph, I'd be like, okay, -infinity to -4, and -4 to 2, and 2 to infinity. So this has three pieces based on the graph, so I need three intervals to write it down, right? So we could even make it more clear. Here's my first piece, right? Here's my second piece. Okay, so how in the world do we do this by hand? Well, I'm going to show you, but first let's figure out why these values are not allowed. Right, so let's take f of 2 on my calculator. So I just plugged in the function and I took out every x and put in a 2. And let's see what happens. So if you look at this error that the calculator gives you, it gives us a hint, right? Divide by 0, it says. Notice if I put in just the denominator, I get 0. So that makes sense why that's not part of our domain, right? We know that dividing by 0 is undefined. So for this particular case, the way we would do this by hand, not given the graph, is I'd be like, well, I need to find when my denominator is equal to 0. And notice this is the type of equation you know how to solve, right? So I would solve by factoring. And what is this one? So we get +4 minus 2, right? Because -2 times 4 is -8. -2 plus 4 is my 2. And then I set each piece equal to 0. And look what I get, right? I get negative. But this is not my answer, right? These are the values that are not allowed. So that's what we're solving for. That's the key fact to keep in mind. We're solving for values that are not allowed here when we're setting the denominator equal to 0. So then when I write down my domain, my answer is, well, everything else will be from -infinity to -4. And I have to go left to right. -4 to 2. And then from 2 to infinity. So putting these in the proper order matters, right? So you have to know where these guys are on the number line. Okay. So that's how we do these by hand. So notice we are taking an idea that you're already familiar with, the domain, and pairing it with a skill that you already have, which is solving quadratic equations by factoring. But these rational functions are not the only functions that we see in the wild. We have other functions involving square roots that are going to require other strategies. We're going to start with g of x, and then we'll do f of x. They're very similar. Notice they both have this 2x plus 8, but they have one key difference. And my rule here is no negatives in the square root, right? So my strategy for tackling this one is going to be a little bit different. I'm going to be like, okay, 2x plus 8 must be greater than or equal to 0. And then I can solve that inequality, right? So this says my inside cannot be negative. And then here is my domain. X must be greater than or equal to -4. And then how do I write that down? Well, -4 gets a bracket, and then greater than or equal to would be from -4 to infinity. Okay. At first glance, f of x looks to be the same. It looks to be like, if I'm following the same rule, 2x plus 8 greater than or equal to 0. Right? But this is actually wrong. So my rule still applies, but also my rule from my first function applies as well. No 0 in the denominator. So instead of saying greater than or equal to 0, I say strictly greater than. And then, of course, my algebraic work is essentially the same. But my domain now, notice, gets a parentheses instead of a bracket. Okay. So that is how you do these. That's how you solve for some of these domains by hand. This increasingly is what we're going to be doing here as you take more and more advanced math, right? So I'm using some of my reasoning skills about the properties of these things, and then the algebraic work I do gets me to the answer from my reasoning.